Hi everybody, in this video we're going to talk about finding distances and finding midpoints. So over here we have a right triangle, and a right triangle is very special because it has something called a hypotenuse, and a hypotenuse is directly across from the 90-degree angle, and the other two sides are called the legs. So what we're going to do first is find the length of the green leg of this right triangle, and that's 1, 2, 3, 4. And then I'm going to find the length of the other leg of the right triangle, and that is 3. 1, 2, 3. Let me make that look more like a 3. And our goal is to find the length of the blue side, the hypotenuse of the right triangle. Now we can't just count the boxes because it's a slanted line. So that's where we're going to have to do something a little bit different. Luckily, here we have a right triangle, so we can use something called the Pythagorean theorem. And that is a squared plus b squared is equal to c squared. If you haven't seen the Pythagorean theorem before, A and B are the legs of the right triangle. It doesn't matter the order. And C is the hypotenuse. So I'm going to put one of the legs in for A and the other leg in for B. And I don't know what the hypotenuse is yet. That's actually the length that we're solving for. So I'm going to leave that as C. So here we have 16 plus 9 is equal to c squared. So that's 25 is equal to c squared. To get c by itself, we take the square root, and we have that c is equal to 5. So the length of the hypotenuse, this slanted line over here, is 5 units long. Now let's take a second and let's think about what we did here in order to find the length of the slanted side of the hypotenuse. So one of our legs was the change in the x coordinates, because notice how we were moving along the x-axis left and right to figure out how long this red side was. And we can write the change in the x coordinates as x2 minus x1. And when we put it into the Pythagorean theorem, it was squared, and there was a plus in between. To find the other leg, we were looking at the change in the y-coordinates because we were moving up and down along the y-axis. So we can denote the change in the y-coordinates as y2 minus y1. In the Pythagorean theorem, it was squared. And then to get c by itself, the hypotenuse by itself in the Pythagorean theorem, we had to take the square root of both sides. And that gives us our distance formula. So the purpose of this was just to make the connection between the Pythagorean theorem and the distance formula. You can use either one to find distances. They both do the same exact thing. They find the length of a line segment. If you want to use the Pythagorean theorem, it's probably better off if you have graph paper, so that way you can form your right triangle, because sometimes you'll just have the line segment, the slanted line, and they won't give you the rest of the right triangle, so you'll have to use graph paper and draw that yourself. Distance formula is useful because as long as you know the distance formula, you don't need graph paper. You can find the length of any line segment just by plugging in the coordinates. Let's practice using the distance formula to find the length of the line segment. So the distance formula is change in x squared plus the change in y squared with a radical over the whole thing. So let me label my points. I'm going to label this x1, y1, x2, y2, just so I don't get confused when I'm plugging in. So we have -9 minus 6, and we have -4 minus 4. Definitely use a calculator for this part. You don't want to make a mistake with the negative numbers. That is -15 squared. That is, oops, my pen slipped. -8 squared. So take a second and put this into your calculator. You should put just what's underneath the radical into your calculator. The reason for that is if it doesn't work out to be a whole number and you put the whole radical into the calculator, it's going to give you a decimal that goes on forever, so you're going to be rounding. But if a question doesn't say the round, we want the exact value. And the exact value is a radical if it doesn't simplify any further. So -15 squared is 225 plus 64, because that's what 8 squared is. So we have radical 289. And in this case, radical 289 does simplify to a whole number. The length of the line segment is 17. But leaving the radical in each step and not putting it into your calculator ensures that you get the exact value at the end and that you don't get a rounded answer if the question doesn't specifically tell you to round. Let's take a look at this next example. So we have a triangle that has the following coordinates, A, B, and C. Show that the triangle has two congruent sides, but not three congruent sides. So to show that sides are congruent, we need to show that they have the same measurement. So we need to find the lengths of the sides in order to compare them. And when we need to find lengths of line segments, that is distance formula. So I'm just going to make a really quick graph of the points. I don't have graph paper, but negative one would be somewhere down here. 4, 0 would be somewhere over here, and 0, 4 would be somewhere over here. Oops, let's see. Just so we can get a sense with what we're working with. So we have this side of the triangle AC, this side of the triangle CB, and this side of the triangle AB. I'm going to start with AC. I don't know why I'm going to start with AC, but I'm going to. So our distance formula, if we're using points A and C, x2 minus x1, 0 minus -1. Be careful with the negatives. The negative was part of the distance formula. It was x2 minus x1 squared. And then when I plugged in x1, it had a negative. So that's why you see two negatives here. That one was part of the distance formula, and that one is attached to the number that we're plugging in. Okay, and now we need y2 minus y1. And I'm just going to put what's underneath the radical into my calculator all in one shot. So I'm going to put in 0 minus -1 squared plus 4 minus -1 squared. And when I hit enter, I get 26 underneath the radical. That's an example of when you're not going to want to put the radical into the calculator, because if you type radical 26 in, you get a really, really long decimal that goes on forever because it doesn't simplify to a whole number. That means it's irrational. So since the question doesn't ask us to round, leaving it as the radical would be the exact value. Okay, now I'm going to do side CB. So CB is with these two coordinates. So x2 minus x1, that would be 0 minus 4 squared. Y2 minus y1, 4 minus 0 squared. And once again, I'm just going to type in everything that's underneath the radical exactly the way I see it. 0 minus 4 squared plus 4 minus 0 squared. And I got 32 for what's underneath the radical. And once again, radical 32 doesn't simplify to be a whole number. It's not a perfect square 32, so I'm just going to leave it as is. And then finally, our last side is AB. I should probably use a different color for AB. So that is this and this. So let me get my radical so I don't forget it. So x2 minus x1 y2 minus y1 squared. Once again, going to type in everything that's underneath the radical, 4 minus -1 squared plus 0 minus -1 squared, and I got 26. So here we can see AC and AB are congruent, but CB is not. So we just showed that two sides of the triangle were equal, were congruent to each other, but the third side wasn't. Now we're just going to talk a little bit about midpoints. So the midpoint is the middle of a line segment. So if you have a line segment, the midpoint is the point that splits it equally into two congruent parts. You can think of midpoint as the average because the average is the middle, basically. So when you're finding the average of your test scores, you add them up and you divide by the number that there are. For example, if you took two tests and you scored a 90 and a 100 on those two tests, to find the average, you would do 90 plus 100, the two test scores, and then divide by 2, the number of tests that you took. It's the same thing when we're finding the midpoint of the line segment. We're going to take the average of the x coordinates and the average of the y coordinates. So the midpoint formula is the average of the x coordinates, comma, the average of the y coordinates. So let's plug in. So with our endpoints here, our x coordinates are 2 and 8. And there's two x coordinates. That's why we're dividing by 2 to average them. Same thing with the y coordinates. There's 2 y coordinates. That's why we're dividing by 2 to average them. So that would be 10 over 2. And 10 over 2 is 5. And this would be negative 2 over 2. And negative 2 over 2 is negative 1. So the midpoint of the line segment here would be 5, negative 1. Okay, let's do another one. Once again, we're given endpoints and we need to find the coordinates of the midpoint. So midpoint formula, once again, is the average of the x coordinates, comma, the average of the y coordinates. So that would be 4 over 2, comma, negative 2 over 2. So that's 2, comma, negative 1. So the midpoint of the line segment would be 2, negative 1. Let's take a look at this next one together. So here we have a quadrilateral. That just means a four-sided figure. And what we need to do is find the coordinates of the midpoint of diagonal AC. So we don't see AC here, so I'm going to draw that. And we're going to figure out what the midpoint of that segment is. We know what A is. We know A is negative 5, 1. And we know what C is. We know that C is 3, 5. So we know the coordinates of the endpoints. So we can use midpoint formula, average of the x coordinates, comma, average of the y coordinates in order to find the midpoint of the line segment. So that would be negative 2 over 2, comma, 6 over 2. So that's negative 1, comma, 3. And there we found the coordinates of the midpoint. If I go on my graph, negative 1, 1, 2, 3, notice how that's exactly in the middle. This is the last one we're going to do in this video, and this one's a little bit different. And the reason why it's different is because if you take a second and you read the question, instead of being given both of the endpoints, this time we're actually given the midpoint. The coordinates of the midpoint of the line segment are 2, 4. So I'm going to label that M because that's actually the midpoint of the line segment AB. And it says the coordinates of point B, which is one of the endpoints, are 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And we need to find point A. So I know it's going to be somewhere down there, but we need to find exactly where. So remember that a midpoint splits a line segment equally. So both halves from endpoint to midpoint and from midpoint to other endpoint should be congruent to each other, should be the same distance, the same movement. So to get from the midpoint to this endpoint, we go right 1 and 1, 2, 3 up. So right 1 and 3 up. So if we do the reverse on the other side, we should get the other endpoint. So let's go left 1 and 1, 2, 3 down. And that should give us point A. And that is the point 1, 1. You can also do this algebraically using the midpoint formula as well. And that can be helpful, especially in situations where your coordinates are really large and they don't fit on the grid, or if you don't have graph paper. So I want to go through how to do that. So the midpoint formula is the average of the x coordinates, comma, the average of the y coordinates. So let's take each of these separately. we know what the midpoint is. So we know that when we average the x coordinates, we ended up with the midpoint x coordinate of 2. And we know that when we average the y coordinates, we ended up with the y coordinate of the midpoint, which is 4. So now we just need to backtrack and figure out what the other x and y coordinate was. So we already knew what one of our x coordinates was of one of the endpoints and what one of the y coordinates was of the other of that endpoint as well. So point B was the endpoint we're given, and we're given that the x coordinate is 3, and we're given that the y coordinate of that point was 7. So now we only have one thing missing that we can solve for. So let's solve. To get rid of this division by 2, I'm going to multiply by 2 on both sides. So what I have here is 3 plus x2 equal to 4, because 2 times 2 is 4. And then subtract 3 to get x2 by itself. So x2 is equal to 1. So far, so good. That's matching up with the x coordinate we got here. Okay, let's multiply both sides by 2 to get rid of this division by 2. And now we just need to get y2 by itself. So we're just going to subtract 7 from both sides. And we have y2 is 1. So we got the same x and y coordinate of the endpoint that we got graphically. It's just good to know how to do both.